everyone. Welcome to Interstellar. It's a pleasure providing content to you in the past 2.5 months. It has been a pleasure to provide you content related to all things space in the past 2.5 months. And we've been contemplating to bring you newer content, something that will not only inform you but also educate you. As you all know, I'm not only the editor of Interstellar, but in my previous life, in my previous careers, I've also been a space scientist. And there's so much happening in the world of science, in the world of space science, that needs to be brought to the fore for you, for your increasing your knowledge, for giving you all the updates and making them relevant to the contemporary times. One such event has happened uh, in the field of planetary sciences. Now, this is something what I believe is of great interest to many students, to all the enthusiasts who have been following planetary science and exploration, and for them, this particular news has brought great respite and great excitement at the same time, and that is about the discovery of phosphorus in the plumes of Enceladus. Now you must be thinking, what am I talking about? Here on Interstellar, we've always been discussing about the space technology, space economy, and all other things. But space science is something that we seldom dived into. But with this episode, we've made it clear, and we are sort of determined that we will be covering a lot of space science in Interstellar. So I just spoke to you about Enceladus. Now, this is one of the very fascinating moons in the outer solar system. It belongs to Saturn, and this particular moon has an ocean on it. Now, very few satellites of our planets, the planets in our solar system, can boast of of an ocean, and Enceladus is one of it. This Enceladus uh, not only has an ocean, but quite frequently it shows a lot of volcanic activity. And when I say volcanism, this is not volcanism of lava. This is volcanism of icy plumes. So imagine a moon which is covered with water, and due to its internal tectonic activities, it releases some of this water ice into the atmosphere and also into outer space, because the atmosphere of this particular moon is quite tenuous. It is quite thin. So this particular moon is being researched by a spacecraft called as Cassini since the past 15 odd years. Now, very few spacecraft can boast of such, really, long operations and functions, and Cassini is one of them. It has always uh, delivered, really exciting science about the Saturnian system, Saturn, as well as the moons of Saturn, as well as other bodies that are in the vicinity. So, very recently, one of the payloads, one of the instruments which is on board Cassini, it is called Cassini Cosmic Dust Analyzer. So, the team that is working on it published a really interesting report where they were assessing the chemical composition of these plumes. Now, one would imagine, or even I had imagined uh, in my naivety, that the plume could be only made up of water or water molecules. There couldn't have been much in it. But since we here are talking about volcanism, we are talking about interactions that might be happening between the liquid water that is present in there, as well as the minerals that are present in the rocks that are beneath the ocean. There might be more to the chemical composition of this water. And since at this point in time it is difficult to enter into the oceans and carry out in situ analysis then and there, what Cassini Cosmic Dust Analyzer did was it sort of picked up some of the plumes that came out of the moon into the Enceladus orbit. And it picked up the samples on the spacecraft and sort of measured it. Now, this cosmic dust analyzer, in its recent report, which has come out only this week, has said that this moon perhaps has water which consists of phosphorus. Now, you would imagine phosphorus, what's any other element? What is it so great about it? What is so great about it? You know, the entire enterprise of humans and any countries to be precise, going out in outer space is that we are going out to find out life. We are going in the search of life. And it could be intelligent life, it could be non intelligent life. And the chances of finding non intelligent life are considered a bit higher. Within our solar system, there are quite a few bodies which can harbor life, and Enceladus is one of it. And for Enceladus to harbor life that is native to that particular moon, it needs to have certain chemical composition. And if you look at life here on Earth, here on Earth is made up of quite crucial elements: carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. Now, where is phosphorus used in our life forms? You know, ATP. So, some of you who might have studied class 10, class 11, class 12 biology, you might have heard about the word adenosine triphosphate. You might have heard about the word adenosine diphosphate. So, this is considered as the currency, energy currency of our bodily cells. So, not just humans, but all cells, animal life, plant life here on Earth. So phosphorus is important to provide energy to a lot of cellular activities. And since we are multicellular organism, the energy that is generated by cell translates into energy in all the activities that human and plant life carry out. So finding that very phosphorus in the plumes of Enceladus is actually an exciting discovery. Now, has it led to life? That is yet to be seen. But when the scientists who are associated with this particular instrument, cosmic dust analyzer, they found phosphorus in an inorganic form. It's not in an organic form. It is not associated with an organic molecule, but it is in the form of a mineral which is called as hydroxyapatite. Now, this hydroxyapatite is formed at really low temperatures, and it is usually associated with calcium. It is usually associated with really simple base bases, elements that form bases. And this hydroxyapatite has been detected in the plumes of Enceladus. Now, what is so great about it? Firstly, if there is any life form lying at the bottom of Enceladus, at the bottom of the ocean floor of Enceladus, then that life form might use this hydroxyapatite. Now, this is a conjecture, but this is a scientifically validated conjecture that I am talking about. Similarly, if you come to the moon, if you come to our moon, the entire talk about finding water on the south and the north pole of our moon is also driven by two purposes. One purpose of finding water is to use the same water as a fuel for consumption there, then and there, by humans that would eventually set up habitats around the South Pole. And the other aspect of searching for water is if you find water, you might also find life on the moon. It might not be the same life as we find here, even if it is very simple, but that life form might be very unique. And that's why a lot of astrobiologists, a lot of scientists who are engaging in origins of life are not only now seeking water, but they're also seeking various signatures of these CHONSP, which we call as John SP elements in various forms, because it is the chemistry that happens between the water, in the water, the chemistry that happens between these elements in the presence of some energy form. Now, in case of Enceladus, the energy form could be uh, the relatively high temperatures. The temperatures would not be as low as, let's say, minus 90 Kelvin or minus 100 Kelvin. It might be slightly higher if the tectonic activity generates some friction or geological, heat. And on the moon, since there is very less geological heat, tectonism is absolutely or near absent. The energy form would be the radiation that is coming out of the sun, the solar radiation, as well as the radiation that is emanating from galactic cosmic rays. So we are looking at two different types of uh, organic chemistry on our moon as well as on the moon that we are talking about here, and that is Enceladus. So this is not the only phosphorus discovery that has happened in the past 10 years or so. Just last year, the Japanese spacecraft Hayabusa 2 detected uh, some traces of phosphorus on the asteroid, which is which the Japanese call, or which everybody calls now, as Ryugu. Now, Ryugu is a carbonaceous asteroid, and Hayabusa 2 went some years ago to this particular asteroid. It reached there, it picked up samples, and the samples were brought back to the Earth. And while these samples were being analyzed, uh, there were traces of phosphorus found amongst quite a variety of other very interesting organic compounds. One compound of great interest that was found on the Ryugu samples was uracil. And as most of you all know, uracils are extremely important for life on Earth. They are the building blocks of proteins. Proteins are building blocks of DNA and RNA. You consume proteins in your daily dietary needs. You consume amino acids, especially those who are working in gyms, as a supplement, as a drink, while you exercise strenuously. So, amino acid of great importance, and we found, or Hayabusa 2 scientists have found, uracil in the Ryugu samples. Along with uracil, Ryugu samples also showed the presence of vitamin B3. Now, what are the odds of finding a vitamin B3 on an asteroid? Now, this is again a supplement that we use, and finding supplements, finding building blocks of life on an asteroid sample is quite unique. Now, let me be very clear over here. These are not the first instances where amino acid or vitamin has been discovered in extraterrestrial samples. Meteorites that have been falling on Earth since antiquity, even before humankind, even before dinosaurs. Some of these meteorites, when they were analyzed here by scientists in their laboratories here on Earth, and these are fallen meteorites that I am talking about, these meteorites have also shown the presence of various amino acids as well as vitamins. But problem with detecting such biologically relevant uh, molecules is that you might think that these have entered into meteorites from the life that is present here on Earth. So that means you are not very sure about detecting or extraterrestrial vitamins. But when scientists got access to the samples that were brought back to Earth in an encapsulated manner, and when they were presented to the various scientific groups all over the world for detailed analysis, the scientific groups were quite happy because this is for the first time you're getting access to really pristine samples. None of these samples that were brought by Hayabusa 2 were exposed to terrestrial environments. These were not samples of meteorites that have fallen on ground or have interacted with, let's say, plant forms or animal forms, so on and so forth. So these were really pristine samples. So the bottom line over here is we've detected phosphorus for the second time. We've detected not just second time. I remember a few years ago, the space mission Rosetta. when the Rosetta orbiter was going around the comet, this was around 2014, 15, and 16, it picked up some signals of phosphorus along with some signals of it was a very faint signal of some amino acid, uh, and a very simple amino acid. So these are not the first instances. And if you look at this entire discovery in totality, you will find that the space around us, the small bodies that fly around us, be it asteroids, be it comets, be it moons of great interest to astrobiology, be it Enceladus, Europa, so on and so forth. These are all really rich in organic material. And when there are organic material in such abundances, one tends to think whether life on Earth is a product of all the processes that have happened here on Earth. Is life on Earth really indigenous to Earth? Or is life on Earth made up of materials that have existed here on Earth in addition to ingredients that get sprinkled in the form of asteroid impact, in the form of meteorite impact every now and then? Scientists estimate that nearly 500,000 tons of meteoric material comes to the Earth every year. So this meteoric material could be size of a large car, which might be falling into the oceans and it might be going undetected, or it could be really small particles. It could be really small pebbles that could be entering into the Earth's atmosphere. And when these small particles, pebbles, or large bolides, or the large chunks, if they fall down on Earth, they not just fall here, but when they mix with oceanic waters, when they mix with our grounds, they sort of give away all that they consist of. They give away all the chemical elements, or they give away all the chemical compounds that they have brought to the earth. And once these chemical elements sort of merge with the terrestrial chemistry, the earthly chemistry, then you are actually benefiting from it. So these are not the materials that are available on Earth for life forms to consume. But once they come in the form of asteroids or meteorites, then life on Earth benefits from it. So the broad conclusion that we can derive from this particular discovery is that number one, as we go to the moon, our moon, or any other moons, we'll have to make sure that certain areas of great astrobiological interest or astrochemical interest need to be cordoned off. They need not be explored left, right, and center. You have to be very careful because you do not want to contaminate these sensitive zones with the chemistry or with the biota that you're carrying on your bodies or on your instruments. So you will have to prevent forward contamination. And this is not just responsibility of one country, this is the responsibility of the entire world. Forward contamination needs to be prevented because discoveries like the phosphorus on Enceladus, the phosphorus, uracil, and vitamin B3 on Ryugu, they all point to the fact that we really don't know how life on Earth formed, whether these elements which are present there on these extraterrestrial bodies could lead to life there, and we do not know how life on Earth or life elsewhere could interact with each other. COVID 19, the SARS-CoV-2 virus, it was completely alien to the human body and it wreaked havoc in the past 3.5 years. The COVID 19, the SARS-CoV-2 virus was alien to us. And similarly, alien to us would be any life form that is present on Enceladus or on the moon or on asteroids or comets. We haven't detected life forms yet, but with continuous analysis that is going on by The current mission, the missions in the past, as well as the missions to come, will only give us a grander picture of where life on Earth stands. Is it entirely autonomous? Are we entirely earthly? Or are we a products of a hodgepodge of extraterrestrial and terrestrial chemistry? So, until we find that out, we need to be very careful about our approach to outer space, and we'll have to sort of, you know, we'll have to sort of uh, ration the way we go into outer space. So that's it with this episode. Tell us how you like this episode by liking this video, by subscribing to our channel, and following us on various social media handles. We are open to your queries, questions. We are open to your suggestions. And let's keep this interactive. Interstellar is interactive with you all. Thank you.